Good afternoon and a very warm welcome to episode 2 of the NOCN Eat Your Green series. This webinar will introduce you to solar PV, EV and battery storage. The Eat Your Green series is brought to you by FE Week and Educationscape in partnership with lead sponsor NOCN, who will lead the webinar today with input from industry guests HS Energy Group. I will shortly hand over to Graham Hastings-Evans, Chief Executive of NOCN, but before I do, I'd like to add that there will be sufficient time at the end of the webinar to answer any questions. Please use the question and answer feature within Zoom to submit your questions, which may be answered via the Q&A feature throughout the webinar. But just to note, any questions answered verbally will be at the end of all the presentations. I would like to thank our sponsor and industry guest and now welcome Graham Hastings-Evans from NOCN and invite him to present the webinar. Thank you.
Thanks very much, Joe. Welcome, everybody. I'm going to do a short introduction covering off where we are with policy and also to explain something about something called GSAP, which we are heavily involved with as well. So next, please. I think we're all aware that we've got probably one of the busiest policy changes period ever, with everything being pushed forward at a rapid rate of knots. Clearly, in terms of the areas we're talking about today, we've got the mission to build 1.5 million homes and to make those homes all warm homes, to ensure that they're the best we can do in terms of insulation, using solar, heat pumps, and make them as green and as carbon free as possible. And sitting alongside of that is the thrust on clean energy, which is all around power, mainly around power generation, as well as power distribution. So two major areas, and some of you will also have heard that for England, there is something like £600 million worth of extra funding going into skills in construction to support those two major missions of the new government. And to actually move that forward, there is a joint board called the Construction Skills Mission Board, which is chaired by the Deputy Prime Minister, Angela Rayner, and the Chief Executive of MACE and Chair of the Construction Leadership Council, Mark Reynolds. And that has its first major meeting actually next week. So some of us have been engaged in feeding stuff through for that board. We also have construction regulation coming along, and the move to improve competency frameworks and be clear about the skills that people need through the Super Sectors program, which has run through the Department of Business and Trade and the Construction Leadership Council. So a lot happening there, some major stuff. Whilst level 2 and level 3 reviews have been taking place, we've got the curriculum review 16 to 19 here, what that says back end of this year. Pilots have started for redesign of the way EPA works. Carpentry and joinery is the first one to pilot in construction. That's happening now. It's just kicking off. There's foundation apprenticeships for some things, generally around house building. The new installation apprenticeship is out, and a real move to modular and stackable learning, because yes, we've got to train young people to come into the industry through apprenticeships, through qualifications. But one of the massive tasks that we've got to face is to upskill the existing workforce. So unless we desperately need modular and stackable learning to do that. Next, please. So that's the overall sort of policy. I mentioned that NOCN has been involved with something called the Green Skills Advisory Panel, bit of a funny name in some ways. But about 3 years ago, we, with Exeter College and a few others, felt somehow we needed to get a program going to push forward green skills, to engage employers, housing corporations, manufacturers, material suppliers, schools in this journey to move forward all our skills towards net zero, and people had the skills necessary to do whatever that was, fix solar panels, understand the importance of those. And that started about 3 years ago with a clear mission and vision and values. You'll get a copy of these slides, so I'm not going to read everything out. We kicked that off, and it's really been making good progress. And you know, we promised to do something, we do it, and that's been one of the great things about it. And it's having everybody round the table: private training providers, the colleges, the universities, the housing associations, the local government, the major employers, everybody around the table going, we're going to really do something about the skills needed to get us to net zero in our region and in our area. And that it's been a very successful initiative that was kicked off and piloted in the Southwest. It's now grown. Next, please. So we've got a number that are of GSAPs that are happening in the UK, but also a number starting to grow overseas as well. I'll just show you very briefly a list. Next, please. So these are the ones in the UK. If you're interested, by all means, engage with them, contact us, and we'll be able to put you into link. So they will be the ones that you may be interested in, just as a passing interest. Next, please. This idea has caught on. So in countries like Malawi, Nepal, and Morocco, they're starting to want to take this concept to improve the skills towards net zero of their people. Thank you very much. That's my introduction, and welcome. I hope you enjoy the rest of this webinar.
Thank you. Thank you very much, Graham. I would now like to introduce Tom Winter of NOCN Energy Group. Thank you.
Hi, everyone. Just going to share my slides now. So yeah, hi, as Joe kindly introduced, thank you. My name is Tom Winter. I'm here on behalf of NOCN Energy Group Limited. A little bit about us: we're a solar, battery and EV charging specialist organisation. We've been doing this for about 10 years. Myself, as my role in operations director, I've been working with NOCN Energy Group for about 8 to 9 years now. I manage sort of installation teams, the logistics, the operations, and oversee the sort of projects that we're working on through to completion. Today, I'm going to talk a little bit about the practical side of what these technologies are, sort of how they work, what the key components are, what the installation process looks like, because it's something people might not consider all the time. What practical considerations do we need to do within the industry, what the benefits are, what the government involvement is, and what the future holds. So going straight into how it works, start off with solar PV. So solar, obviously, sort of in the name, it works with sunlight. Effectively, what happens with solar is you get a solar photovoltaic cell is within a solar panel. Solar or photons from sunlight strike that, and they free electrons within the material, creating a charge difference, which produces a current. That current is what's called DC current, so it's direct current, which is different to the current that's used within your home appliances. So that current is passed through what's called an inverter, which we'll get onto, and that inverter inverts the current from direct current to alternate current for your home appliances and energy demands. When solar is produced, it's sort of produced right there and then. It's got 3 places it can go, really. It can be used at source, so to power your appliances and energy demand in that moment. It can either be exported to the grid, for example, when you've got more solar than you need power, or it can be stored in something like a battery storage unit for use at a later time. Speaking of battery storage systems, battery storage is sort of what it says on the tin. They're typically LFP, so lithium iron phosphate composition now, much sort of safer and the newest wave of technology for batteries. And effectively, their main role with solar is to increase self-consumption and make sure that all the solar you're generating you can use, and it's stored within your property or your business for use at a later date when the sun goes down and you don't have solar power to draw on. You can still take advantage of that renewable energy that you generated earlier and use it to power your appliances. So yeah, you've got three primary functions effectively: store and supply energy when the demand can't be met with solar alone, so it can back up solar and close that gap on the energy demand. Save energy costs by potentially charging your battery when energy rates are cheap and then using it when energy rates are high. Or in certain situations, batteries can be used as a sort of an uninterrupted power supply or an emergency power supply. When the power goes out, you have a battery storage system there that enables you to keep the appliances running. EV charger, pretty simple. Effectively, you're providing energy through the form of a direct connection to the car's charging point. There's lots of different car chargers available. Some are compatible with solar. So a similar way battery works, you can set up a car charger that will trickle the excess solar generation into a car. You obviously have high-speed charge points, and some of these charge points now are intelligent, and they work with sort of energy tariffs to let homeowners or business owners take advantage of competitive rates when they can charge their car at a cheaper rate. In essence, it's providing power to the car, not through fossil fuels, through electricity. I'm going to speak on the components quickly. Obviously, you've got solar panels. Solar panels, the big one here. They're typically measured in watts as a rating. So as in the industry, you might often hear us refer to panels in their wattage. So you might say that's a 400 watt panel. And what that measurement means is that's the amount of watts, the amount of energy that panel could produce within 1 hour. Now that'll be an hour of sort of great sunlight or sort of lab conditions, but in theory, that panel's rated to produce up to 400 watts. When we get an array of solar panels, we'll typically refer to them by the cumulative output. So if you had 10 400 watt panels, we would refer to that as a 4 kilowatt system, for example, because I might refer to that a little bit later, so you know what's going on. But yeah, they're comprised of cells, solar cells. They're sort of laminate glass with aluminium frames, and they're the power generation points. Obviously spoke earlier about the inverter. Inverters are really sort of important part of the setup. Inverters come in all different shapes and sizes. Could be from a sort of shoebox up to a boiler. You can get inverters that go on the back of panels, or sort of massive industry grade inverters. But effectively, their main job is to invert the current being generated from the panels to usable current for use within the property. It's the brain of the operation. It's where you would make settings changes, upgrade firmware. You would provide your monitoring so you can see how much your solar is producing. And we would sort of rate them in accordance to the size of the system that they're attached to. Like I said, there's loads of different inverters, each with their own use case, but I could fill another webinar with that, so we'll leave it there for the moment. Mounting system, something that people don't really consider, but ultimately when solar gets up onto a roof, you need something to affix it, make sure it's safe, compliant, and it's going to enable you to have a long-lasting and reliable solar array. I'll get on a little bit about how we actually install those, and what the mounting system actually looks like when you go up on a roof and actually end up putting panels on in the installation process. Battery storage as well, like I said, it's LFP, lithium iron phosphate composition, and similar hours. So a 3 kilowatt hour battery could in theory supply a 3 kilowatt load for 1 hour or a 1 kilowatt load for 3 hours. So you can have batteries that range from 2 or 3 kilowatt hours all the way up to mega sort of containerized style battery system with hundreds of kilowatt hours worth of storage for sort of commercial use and really anything in between. And yeah, their main use is to store energy for use at a later time. EV chargers, you get different types of EV chargers. You can get residential chargers, which are AC chargers. They're the slower chargers typically. So that's your 7 kilowatt for single phase and your 22 kilowatt for 3-phase. And what those are chargers that have to use the car's inbuilt inverter, because the car's battery energy is DC current. So they have to use the inverter that's inbuilt to the car to invert that current back to DC, which is why our DC rapid chargers are much quicker, because they can bypass that. And those are the ones you'll find at service stations or sort of high volume sort of superchargers, or the big ones, the sort of ultra rapid and the hyperchargers. They bypass the onboard inverter of the vehicle and put DC current directly into the battery for a faster charge. To talk quickly about the installation process, so I've got a little sort of diagram here to demonstrate what I'm talking about. The first process, when we go up and do it on a roof, and this could be the same domestically or residentially, it's to install what are called mounting anchors or roof hooks. And these are effectively bolted onto the frame of the roof, and they carry the weight. They take all the weight of the array. You'll sort of install them within lines across the next component that we'll talk about, and the tiles will slip back over the mounting anchor to ensure the roof remains watertight. You then apply mounting rails to the roof hooks. They'll run across the length of the array, and that's ultimately what we end up bolting the panels to. Now these are aluminium rails. Sorry, they're really sort of sturdy. They're weather resistant a lot of the time. So they're sort of parts of the components that are really reliable, and that's what the panels get mounted onto. So ultimately, you place the panels on those rails, and those rails and the mounting anchors, they take the weight. And you put the panels on there, and you'll bolt the panels to the rail using what are called clamps. You'll have clamps for the middle of the panels and clamps for the end of the panels. But ultimately, for the most part, that's the composition of a system on a domestic scale. But obviously, there are businesses where that applies to as well on a commercial project scale. If you ever look at sort of solar panels around your street, you'll probably be able to piece that together now and be able to identify what the different components are. On the electrical installation side, so what an electrician's job involves, so probably should have prefaced that. Typically, you'll have a team of roofing professionals and a team of electrical professionals. Roofing professionals putting the panels on the roof and liaising with the electricians to get the internal workings and the electrics sorted for the solar system. But typically, the electricians will be taking the DC cable from the roof, and they'll be plugging that into the inverter with isolation points either side, so we can monitor and we can use isolation to maintain the systems. We can stop power going either to the inverter or from the inverter, be that with a DC isolation point or an AC isolation point, as you see in the graph. The electrician will mount the inverter, install the battery systems, do all the wiring on the home side of it, and ultimately connect the system up to the property's consumer unit and electrical load. So what are the practical considerations? So obviously solar, there's a lot we've got to consider, but one of the biggest ones is sort of roof space and access. The solar panels, I think, are bigger than everyone thinks they are. As the industry's grown, panels have got bigger, but roofs haven't got bigger. So a typical solar array can sort of require anywhere really from 20 to 30 square meters of clear roof space. And that you're only talking about 10 to 14 panels. So sometimes it's obviously going to be a lot more. There's lots of things we've got to consider with that in terms of actually, is there enough roof space to fit the array that the client wants? What the roof surface is, whether we need a different mounting system, and obviously being sort of health and safety conscious, knowing that we need safe access for our engineers. We've got to work at height, we've got to make considerations regarding fall protection, material loading, and safe working ability. So that's something that is all within our thought process when we're speccing jobs and being able to deliver solar systems. Orientation and performance is a massive thing as well. When you get solar installed, you want to know how much it's going to generate. You want to know what roof face is going to be best for you. Obviously, we've got the sort of sun path diagram there. South facing is typically considered the best sort of for overall power generation. However, there's a great misconception that east and west aren't great there, where that's completely sort of not true. East-west roofs we're a big fan of. If you've got an east or west roof, that's completely viable. It will just depend on what your sort of self-usage habits are, whether you want power being generated in the first half of the day or the second half of the day. But yeah, we can certainly have to sort of consider that when we're providing estimates or performance metrics for our customers. That graph on the right is showing you a little bit about the UK solar radiation map. So it's effectively telling you what parts of the country get more sun than others. I'm luckily down in Brighton, so I'm in the red zone. So we get nice and the most amount of the sun over here. And sort of as you move further up, we sort of have to consider that in our estimates for when we're installing solar. Another big thing, which is sort of the paperwork side of it, is our liaison with the grid and the electrical network in that area. So when we're installing solar, what we're effectively doing is we're putting a little mini generating power plant onto the energy grid. So you can imagine a world in which everyone started doing that and they didn't tell the electricity distribution network in their area that they were doing that. So UK Power Networks down in this way for us, if we started putting lots of different generating plants within an area, and then this suddenly a power influx to their grid, when the sun came out, they would be in a whole lot of trouble. So what we've got to do is we've got to tell them what we're doing before we do it. Sort of, there's lots of different types of application we can go through, but ultimately we need to tell them the amount of power that we're planning to put in a certain location, so they can see if their local grid infrastructure is going to manage that power effectively and sort of handle it and be okay with it. So that's a big part of what we have to consider. So what are the benefits of solar? So solar obviously provides energy from a source that's not depleted when used. It's a renewable technology. It's something that's going to it's already massive, it's getting bigger, but it's only going to grow. It's something that the world needs. And in the current sort of energy landscape, it's got a big role to play in reducing costs for home and business owners, and ultimately reducing reliance on sort of inflating energy prices. Battery storage is something that within the last sort of 5 or 6 years has become much more vital, and vital as in being coupled with solar PV. It just means that you can get the most amount of benefit from your system, and you can enable self-consumption so much greater when you have a place for that solar power, that free solar energy to be stored, so that you can use it at a later time and not miss out. It leads to environmental benefits and economic benefits for the people purchasing the systems. So what are the government incentives at the minute? So solar has been 0% VAT since April 2022. I think previously to that, it was about 5%. But that obviously is an incentive that sort of helps homeowners specifically. It's not available commercially, but homeowners are able to benefit from 0% VAT on solar as a green technology. The government introduced what's called the SEG tariff, or the Smart Export Guarantee, which is effectively a way that homeowners can get paid on the excess energy that they end up exporting back to the grid. It replaced what was called the feed-in tariff, which was abolished in, I think, April 2019, which was a flat rate of payment for any energy used, any energy generated by a solar array. Obviously, the government are constantly looking at the planning requirements and the permitted development in relation to renewable technology. So seeing that we can get around planning permission, or if you're in a conservation area, a listed building, is there still a way that we can get you solar PV installed and we can hit our green targets and get our goals? Obviously, with that comes net zero by sort of 2025. And obviously solar in the renewable space is going to be a massive part of that. Coupled with the solar PV and air source heat pumps sort of being installed on new homes by 2027. I mean, lots of the new developments now already have solar, so we're sort of beating that target anyway, but that's going to be a sort of mandate and something that everyone's going to have to follow. Increased capacity targets, sort of going up the amount of megawatts of solar that we've got on our shores and within our sort of portfolio as a nation. And then obviously other stuff like the end of the sale of new petrol cars and diesel cars by 2030, meaning the EV infrastructure is something that's going to need massive expansion, and will be something that we really have to grow. And so EV chargers are going to become more a part of daily life than they even are now. There's been some advancements in solar recently. We've got, every year it seems like we get higher and better efficient modules, sort of the solar graph of how efficient these modules and how powerful these modules are for the same area. It gets bigger every year. So it seems like, yeah, every week we're getting bigger panels and the technology's falling behind, but that's a great thing. It means that people are getting great product. Vehicle to grid charging is something that's really new. Not sure how electric vehicle manufacturers are going to feel about it, but effectively what it means is that you can pull energy from your battery to help stabilize the grid, and sort of get paid for that on different tariffs and such. Battery storage and AI is probably going to have its biggest moment in the renewable space with battery storage, and enabling sort of peak shaving, demand response function is going to be absolutely crucial to ensuring that we have a balanced and stable grid network moving forward. Being able to sort of push and pull loads on all the battery sites that are dotted around the country is going to be massive. It's going to be a part that's going to really stabilize our energy network moving forward. And we've got a new sort of technology type called perovskite tandem cells. That's combining a new material with the silicon cell to create a more optimized cell, which has a sort of higher radius of light that it can reach. And again, it's going to be way more efficient. That's pretty new. That's sort of cutting edge stuff, but it's coming and it's exciting. So to summarize, there's lots of sort of practical legislative considerations to the implementation of new renewable technologies. So the industry is going to grow, and as it keeps growing, the skill gap will as well. I started as an apprentice within this space, so the sort of the skills and the learning and development within this space sort of means a lot to me, and I'm a big sort of advocate for it. But as the technology grows, we're going to need to upskill people. Solar PV, battery storage, and EV charging are all going to have massive roles to play for the future of our sort of national and global energy landscape and carbon reduction goals. So it's important that we get the sort of workforce and the people behind it to make sure that we can commit to everything we need to. I believe that's all from me. That's sort of the end of my presentation. So I will end up handing this back.
Thank you. Thank you very much, Tom, for that insightful input on behalf of HS Energy Group. So finally, I'd like to introduce and hand over to Jonathan Alton from the NOCN Tech team, who will complete the presentations for today. Thank you.
I'm just going to quickly share my slides. If you give me 2 seconds so it comes through. Okay, I'm hoping everybody can see that.
Perfect, thank you.
Brilliant, thank you very much. Okay, so yes, my kind of role today is just to kind of look at how NOCN Group have an understanding and a portfolio of products and skills solutions that match the needs for kind of solar PV and EV. I'm going to start by actually considering what the skills gaps are. So for solar PV, you can split those into those 4 areas there, and we'll look in more detail at these in a while. But the key things to consider are the fact that there is a skills gap in design, there's insufficient training for site analysis, being able to actually work out what that array needs to look like. If you think back to the slides we've just seen there, it's about planning whereabouts to place the panels and that kind of aspect as part of the installation process. Talking about installation, there is a shortage of trained workers. So I think we're all aware that solar needs to be on the rise. We've heard the government requirements for 2027 with new homes requiring solar. So as more and more demand is there, the shortage of trained workers is going to prove to be an issue. With that in mind, we'll cover that in a moment. Once the solar PV is installed, the actual day-to-day maintenance and diagnostics is a further area where there is a skills gap currently. There aren't the people, there aren't the bodies out there who can fully diagnose any issues, or even on a small scale, to be able to complete the kind of the cleaning protocols correctly to avoid damage. And then the final kind of solar PV area in terms of a skills gap is assessment and surveying. So looking at accurate shading analysis, structural assessments, and that kind of thing. So there are 4 key solar skills gaps. When we look at the EV side of things, again, we've got another 4 potential skills gaps out there. So same as there was with the solar, there was a shortage in design and refinement. So that is a key starting point. Same again as we had with the solar for the installation as well. There is gaps in electrical installation. So being able to install EV equipment correctly is an area that needs to be worked upon. We need more bodies doing that. Maintenance and repair, there's a lack of training in high voltage work and battery diagnostics, thermal management systems, and all those aspects in and around that. And then the final piece, which is different to the solar one, is the customer service side of things. We need people who can actually explain the benefits of EV charging and running an electric car. So there is still a certain parts of the country where there is a certain level of concern over time it takes in order to charge an EV car, or there's issues around where the network coverage is. So again, that level of customer service, not necessarily a technical skill, but being able to explain to customers what's required and how EV is beneficial to them. So at NOCN, we kind of pride ourselves in making sure that our skills solutions are developed kind of hand in hand with kind of industry and experts. So there's a number of external experts that we've consulted on for the products we're going to talk about in the next few moments. You can see who they are there. I'm not going to read out every single one, but this is a vital part of NOCN's role. We made sure when we are developing a product, when we're launching a new qualification or a new course, that it's accurate, it's got the backing of industry, and it is meeting the needs, those demands we just looked at in terms of skill shortages. I'm going to quickly flick through a couple of slides here, just talking about the different types of skill solutions, qualifications, and courses that we have. And there are numerous, and we are constantly looking to improve and add more and more to these. So in terms of solar, we have got some regulated competency qualifications. These are the MVQs set up there in order to allow people to gain a competency qualification to prove they are working effectively. But we've also got the regulated training side of things as well. So there is a skills shortage. We need to make sure that there are skills being delivered in training environments to people so they can enter the industry and they can start to deal with some of those skill gaps. So we've got, you can see there, a snapshot of 3 of the regulated training qualifications as opposed to competency ones. We also offer short courses as well. So These aren't necessarily a regulated qualification. These are more an introduction, an awareness, or a starting point for retraining. So if you look at the options there, there's an introduction to solar. There's also a solar PV course for roofers. I think as we saw in the previous presentation there, the actual element of attaching those solar PVs to a roof is vitally important. If it's the roofer that are completing that, they need an understanding of what's going on and how it works. What I'll do for the next few slides, though, is then focus more on how our particular products hit some of those skills gaps. So we mentioned the fact that there was a skills gap in and around design. So kind of two key qualifications which we have that designed and put out there to tackle that are the Level 2 award and certificate in fundamental principles of renewable technologies and sustainable energy, and the Level 5 certificate for certified solar photovoltaic practitioner. Both of those, plus the short course at the bottom there, the introduction to solar PV systems, are primarily designed in order to meet and tackle that skills gap. When we look at the installation one, we've got an even wider collection of qualifications that are helping to remove that shortage of trained workers. So it gives people practical experience and training to make sure that they are correct in working safely on a rooftop and completing the wiring aspects. So there's some of the NVQs fall into that, as well as some of the training qualifications, and again, some of those short courses that provide awareness. When it comes to the kind of day-to-day maintenance and diagnostics, that is thoroughly covered in our Level 3 award or Level 3 certificates in solar PV for installers and operators. It's the operator aspect of those qualifications that really looks to cover the kind of day-to-day use, the spotting of errors, diagnosing those correctly, making sure panels are cleaned correctly, all of this to ensure that efficiency is maximised. Okay, final one for solar is all around kind of site assessment. So we're looking at a higher level qualification here on Level 5 in order to make sure that the correct design is taking place, but the correct site assessment is in place before any of the work starts to begin. So again, 3 qualifications there, but the key one is the Level 5. In terms of NOCN as an organisation, we are always looking to support partner training providers, colleges in their delivery of our skills solutions. So for the qualifications and the programmes I've spoken about today, there are a number of support resources available: schemes of work, lesson plans, PowerPoints to deliver some of the aspects of the knowledge. There are learner workbooks and revision notes. There are tutor notes to help those who are delivering the course, as well as kind of additional reading guidance for tutors or for learners on the courses. We also in the main have full assessment design, so the actual assessments that need to take place are well and truly covered as part of our resources to support delivery. I'm going to look at a couple of possible funding streams that can be used in order to help to tackle this skills gap as well, particularly to the boot camps and the LSIFs. So NOCN have designed several boot camps across a number of different sectors. Obviously today I'm just going to focus on the ones around renewable technology. What these do is they bundle together packages of qualifications or units or short courses or training to meet the requirements of what industry needs. These are designed to directly look at solving some of the problems with skill shortages. So as part of that, we have renewable technology boot camps. Ours contains those 3 aspects there. So there's a Level 2 award or certificate in renewable technologies and sustainable energy. There's also what's always vitally important for anything around the construction industry, and awareness of health and safety. And on top of that, we also cover employability skills as well. So the individuals on those boot camps are able to develop their overall skill, develop their overall personality as well, to make them more employable and make them a benefit to the industry and the country as a whole. Also going to speak about LSIFs. So the LSIF funds support particular key areas: investment in new facilities and equipment. And obviously for the delivery of solar, there is a large number of items of equipment required. We saw in the previous presentation a list and some of the kind of functions of some of those aspects. The LSIF funding is available in order to get those facilities and that equipment. LSIF will also help to support development and delivery of new courses and curriculum, and there is funding there for upskilling of teaching staff. My kind of final piece in terms of presentation for this afternoon is around what's coming soon, our future offer. So as this session's around kind of solar PV and EV, you can see what we've got in terms of coming up qualifications: a level 2 certificate in EV battery charging, a level 2 diploma in small vehicle EV technician, and a solar PV for electricians. I think my final slide comes next, which is QR code about more forthcoming events and training opportunities. That kind of brings my presentation to an end there. I shall stop sharing and we can then open out the questions, I believe.
Thank you. Thank you very much, Jonathan. Yes, there are a couple of questions that have come through the Q&A. Not sure if you can see that. Have you got that switched on, Jonathan? If not, I can read those out for you. We've got 2 questions so far.
Yes, by all means, I'll try and answer, or maybe
Yeah,
Tom.
okay. So considering the rapid growth of utility scale solar projects, how significant is the skill gap you observe between technicians trained for the small scale PV systems versus those needed for large scale deployments?
There is definitely a particular set of skills in terms of difference between small scale and the more large scale. And I think what we would expect in terms of the qualifications, the skill solutions that we offer, that they are covering off that full range, so that whether that individual wants to focus on a small scale or a more large scale aspect, those are contained as part of those qualifications.
Thank you. Thank you. And there's another question for Sue, from Sue, but this may be actually not aimed at you. This might be a Tom question, but I understand that there are new regulations around not locating batteries in lofts for solar. So what happens on old installs? Do people need to change? And if so, is there a time limit to comply? And is there any funding available to help with this?
Yeah, so yeah, probably a me one. There is a new regulation around batteries being in loft spaces. It's the PAS, it's the publicly available specification 63100, effectively saying that we're moving battery storage units away from the loft space, preferably to external parts of the building, or at least places with sort of better ventilation and access. In terms of what happens to old installs, that's something that we're trying to get clearer information on. It's not something that we want to apply retrospectively. It's a new regulation, so it wouldn't necessarily affect the installations as long as they were compliant at the time they were done. They would have been compliant when the installation was completed. So there's no need to sort of worry. It's a new regulation. If you're someone who has one of these installations in your loft, it might be worth reaching out to your installer. But it's not a statutory regulation. It's a recommendation. So there's no sort of legal requirement for this for batteries to be moved out of the loft, but it's more of a recommendation. So we're still trying to get clearer information on what the process is for previous installs as well. But I'd advise contacting your installer if you were curious.
Thank you. Thank you very much, Tom. I can't see any more questions coming through at the moment, and we are drawing to an end, but we've had a little tip put into the chat in terms of regarding apprenticeships, and specifically the level 3 junior energy manager app is a great baseline which gives fantastic backbone knowledge. Hope that helps. I don't know if anybody else is aware of that app that gives some useful knowledge for that particular apprenticeship. But if there are no more questions coming through, which I don't think there are,
I think there's another question from Alison in the quick Q&A.
I've just read that one, Karen.
The apprenticeships.
Yeah. Just.
Oh, apologies. I thought I didn't hear you. I do apologise.
That's okay. So I'd like to thank Jonathan for your input, and I'd like to today thank all our presenters, particularly our lead sponsor, NOCN Group, and to Graham Hastings. I'd also like to thank Tom Winter for the input on behalf of HS Energy Group, and finally from Jonathan from the technical team at NOCN Group. Thank you all very much for attending. I think there is a quick question just come up in the chat, but I think we can answer that about any chance to monitor remotely.
I think we might need some more details on that one.
On that one, okay. If they can
Yeah, if that's referring to solar, then yes, everything has a monitoring app nowadays, and you can monitor with a mobile app. But I'm not sure if that was about solar.
if you want to pop any more, yeah, I think we've
Okay.
got a thank you. So I think that answers your question there, Tom. So if there are no further questions to be answered, we can bring the webinar to an end, and to thank you all very much for your attendance this afternoon. Thank you.